Hi guys, I wanted to talk to you about what should be a relatively simple thing, which is how to pick the right size of boiler for your application. Now, the very first problem we encounter is process machinery is generally sold with a requirement of let's say 860 kilograms per hour at 7 bar, where a steam boiler is sold as producing 1,000 kilograms per hour from and at 100 degrees C. Now, what does that mean, from and at 100 degrees C? It sounds to me like that boiler is plenty big enough for that process. The problem that we have is the whole from and at thing. So what we mean by that is to take water at 100 degrees C going into the boiler and turn it into steam at 100 degrees C, leaving the boiler. Now, in our example, we're looking for steam at 7 bar. So I need a little bit more energy to get that water up to 7 bar. And it's really unlikely that you've actually got water at 100 degrees C in the first place. Something like 80 degrees C is much more typical. So I need some more energy now to get the water from 80 as well. And if you go dig your steam tables out and do the maths, you'll find that actually you're looking at around an extra 10% or something like that. In order to convert that from the 860 kilograms an hour at 7 bar that we want to process into a figure that the boiler maker's talking. Now, the next question is, how did the water get to be 80 degrees C in the first place? Now, in reality, you're likely going to have a steam injection unit or something like that attached to that boiler in order to give you a nice stable temperature. So sometimes it's going to be working quite hard because your temperature's dropped off quite low, and other times it's maybe not working quite so much. It's going to very much depend on how you produce your steam. Are you a batch process and therefore your steam demand is quite peaky, or is it continuous process? You've got a nice steady load and a steady amount of condensate coming back that's going to help keep that tank temperature up. So that's not unreasonable for us to expect to use anything from around 5 to 15% extra to keep that feed tank at the right temperature. Now, the other thing we need to consider is the steam's got to travel from the boiler to the point of use. Now, the further that is, the more pipework we're going to need, and all that pipework is going to be hot. And if it's hot, it's losing heat into the surroundings. So, a reasonable 50 mil insulation across all the pipe, all the fittings, all the valves, all nicely bagged up, will probably mean that a 2-inch pipe, 50 metres long, will lose around about 10 kilograms an hour of steam back to condensate. So that's another 10 kilos at 7 bar on top of the steam that we've looked at so far. Another often underestimated heat loss from the boiler comes in the form of boiler blowdown. Now, you are allowed a certain amount of dissolved solids in your boiler. That's going to depend on how big the boiler is and who made it. And how you maintain it at that level is what we call blowdown. So we release some of the contaminated water to drain in order to top it back up again with cleaner water. Now, what your water looks like coming into the boiler is going to depend on where you are in the country, whether the water is coming out of, say, a surface water application, or whether it's from a borehole, how much condensate you've got coming back, and how you actually treat that water, and then what chemicals you put into it before you put it into the boiler. Now, you really need to take some specialist advice before you go too far down the road of buying that new boiler, so that you make sure the water, you know what that water is going to look like going into the boiler and that it looks good. Now, let's assume that we've got around 10% blowdown loss. Now, what that means is that for every 10 litres of water we put into the boiler, so for every 10 kilograms of steam we want to make, we would put 10 kilos of water in. Well, we're going to be putting 1 kilo down the drain. So I actually need 11 kilos of water to make 10 kilos of steam. 1 for the drain, 10 for the steam. Now, if we bring all these numbers together, that means we end up with a from and at rating, the language that the boiler makers talk, of around 1,200 kilos an hour to give us the 860 kilos an hour that we want at our process. So that 1,000 kilogram an hour boiler I mentioned at the start simply wouldn't have been big enough. Now, job done, yeah? Not quite. We've not talked about pressure loss, startup loads, running loads, peak loads, base loads, seasonal demand, environmental permitting, planning permissions, discharge consent, risk assessments, hazardous area assessments.